Hey guys, welcome to another video. So we'll not waste time and start immediately. So today we'll be initially speaking about the universal gas law, and that basically gives us the relationship between the most three important factors when it comes to aviation, and that's what we spoke about yesterday. It is temperature, pressure, and the most important one, density, right? So density basically relates a lot to your performance, like I told you yesterday. So let's start with the universal gas law. So I would like to read to you before we start that the relationship between pressure, density, and temperature is constant. So that's what the whole thing talks about. It might look a bit complicated, but let's look into it, right? So in this particular case, this is pressure divided by density and temperature is equal to constant, right? And this, the whole formula or the universal gas law applies to a perfect gas. That's what it says. It says that this equation only applies to a perfect gas when a given mass occupies a given volume. So it's this equation will not always hold. It might not actually hold in the real world, but in this particular case we are looking into it so that we understand the relationship between density, temperature, and pressure. And there's nothing better than this particular equation to understand it, right? So in this particular case we can also say that pressure, right? And okay, I'll actually relate everything to density. So density is directly proportional to pressure, right? And we can also say that density is inversely proportional to temperature, right? So how does that happen? I know most of you know this. For those who know this, can skip the next, let's say, 1 minute. But otherwise, let's say pressure divided by density and temperature multiplied by temperature is equal to constant. Now for constant we can say, take x. X can be equal to constant, right? Now if I bring this up here, right? If I bring this up here, density, which means pressure divided by temperature is equal to constant. Let's forget the constant for now. So there will be only density left. So that's how pressure can be directly proportional to density, or density can be directly proportional to pressure, and density is inversely proportional to temperature, right? Now we'll get back to the units. Pressure is newtons per meter square. Temperature is absolute temperature, which means it will be in Kelvin, and density is kg per meter cube, right? So one thing I want you to remember, density is directly proportional to pressure and density is inversely proportional to temperature. That basically is your universal gas law, right? Now I'll just erase this and let's again talk about density. Now I want you to imagine two boxes, right? And just for your understanding, I will draw a few molecules. So there are 6 molecules in this particular box, and ten molecules in this particular box. So the first thing that I want you to understand is that air is a mixture of gases, as we spoke yesterday. And now what is gases? Gases is also a bunch of molecules put together, right? So air is a bunch of molecules of different gases put together. So let's imagine 2 of these boxes, right? And in both the boxes there are a few molecules of air. Now when you look at these boxes, in one box there are 5 molecules or 5 dots, right? And in the second box, there are 10 dots, right? Now, if you weigh box 1 and box 2, which one do you think would be heavier? You don't even have to think about it, right? Box 2 will be heavier because there are more molecules of air in it, right? So which box do you think will be denser? Now back to the definition of density, mass per unit volume. So in this unit volume, there is more mass, which makes it denser, more dense, right? So box number 2 is denser. So that basically sums up density for you. Now in the next video, I want to keep these videos short. So in the next video, I want to talk about the relationship between density, temperature and pressure, and also we'll talk about relative humidity and also altitude, right? So that's it for this video. I'm keeping it short so that you can go back and understand what I'm talking about, but we'll come back in the next video really quick and understand its relationship in detail. Happy landings, guys. Cheers.